In this video, we're diving into C operator precedence and associativity. Understanding these concepts is key to writing code where expressions are evaluated as intended. Operator precedence determines which operation is performed first in an expression with more than one operator. Operators with higher precedence are evaluated before operators with lower precedence. Consider this example in the code. We declare an integer variable named result. The result is assigned the result of 5 plus 3 times 2. Multiplication has a higher precedence than addition, so 3 times 2 is evaluated first, resulting in 6. Then, 5 plus 6 is evaluated, which gives us 11. So the final result is 11 and not 16. Now, let's explore a table that highlights some common operator precedence levels in C. At the highest precedence level, denoted as 1, we have operators like function calls, array subscripts, and member access, such as the arrow and dot operators. These operators are evaluated from left to right. Moving down to level 2, we encounter unary operators such as not, bitwise not, increment, decrement, plus, minus, asterisk for dereference, ampersand for address of, and size of. These operators are evaluated from right to left. At level 3, we have multiplication, division, and modulo, which are evaluated from left to right. Addition and subtraction come next at level 4, also evaluated from left to right. Lastly, at level 5, we find assignment operators such as equals, plus equals, minus equals, times equals, divide equals, and modulo equals, evaluated from right to left. Always remember that operators with higher precedence are evaluated before those with lower precedence. And when operators share the same precedence, associativity determines the order of evaluation. Let's understand associativity. Associativity determines the order of evaluation when operators of the same precedence appear in an expression. There are two types of associativity, left to right and right to left. With left to right associativity, operators are evaluated from left to right. With right to left associativity, operators are evaluated from right to left. Let's look at some examples in the code. We declare integer variables a, b, c, and result. In the first example, we have result equals 10 minus 5 minus 2. Since subtraction has left to right associativity, the expression is evaluated as 10 minus 5, which equals 5, then 5 minus 2, which equals 3. So the final result is 3. In the second example, we have a equals b equals c equals 5. Assignment has right to left associativity, so the expression is evaluated as c equals 5, then b equals c, then a equals b. So a, b, and c are all assigned the value of 5. Let's delve into complex expression evaluation. When faced with complex expressions, follow these steps to ensure accurate evaluation. First, identify all the operators present in the expression. Next, determine the precedence of each operator. For operators sharing the same precedence, apply associativity rules. And lastly, use parentheses to override default precedence when needed. Now let's walk through a complex expression example in the code. We initialize integer variables a, b, c, and d with values of 5, 3, 2, and 4 respectively. Then we declare an integer variable named result. Next, we have result equals a plus b times c divided by d minus 1. Following the order of operations, first we perform b times c, which is 3 times 2, resulting in 6. Then 6 is divided by d, which is 6 divided by 4, resulting in 1 because it is integer division. Then a is added to 1, which is 5 plus 1, resulting in 6. Lastly, 6 minus 1 is evaluated, resulting in 5. So result equals 5. Now let's look at another example where we use parenthesis to modify the order of operations. The equation becomes result equals a plus b in parenthesis, times c, divided by d minus 1 in parenthesis. Following the order of operations, we first evaluate a plus b, which is 5 plus 3, resulting in 8. Then we evaluate d minus 1, which is 4 minus 1, resulting in 3. Then 8 times c is evaluated, which is 8 times 2, resulting in 16. Lastly, 16 is divided by 3, resulting in 5 because it is integer division. so result equals 5. Let's explore some best practices and common mistakes when working with C operators. When it comes to best practices, it's advisable to use parentheses to enhance code readability and explicitly define the order of operations. Also, break down complex expressions into simpler ones using intermediate variables. When unsure about precedence, consult the C language reference for clarification. And lastly, avoid relying on obscure precedence rules that might confuse other programmers. Now let's look at some common mistakes. One common mistake is assuming that A and B or C is equivalent to A and in parenthesis B or C when it is actually in parenthesis A and B or C. Another mistake is forgetting that assignment operators have right-to-left associativity. Another one is overlooking that equals equals has higher precedence than bitwise operators but lower than arithmetic operators. And lastly, writing expressions that are overly complex can make code difficult to understand and maintain. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.